Yeah, good evening. In the last videos, I think we discussed about sorting and searching, right? So sorting and searching, we have discussed it very clearly. So in that, how you can able to sort ascending order, how you can able to sort the data in ascending order, and how we can able to sort the elements in descending order. Of course, related to the numbers, numerical values, we discussed very clearly. So after this, we had a discussion of linear search also. Okay. So what is mean by linear search? So searching for an element in a continuation fashion is called as linear search. That means, so whether the data is available or not. First, we will compare with first element. If the data is available, it will return that location. Suppose if the data is not available, it will search in the second location. So it will search for third location. Like that, starting from first location to till end of the location, it will search. So wherever the result is matched, immediately it is going to print the corresponding location. And if the result is not matched, can you please tell me which value it is going to return? Good. So it will return -1. That means if the result is not available, then it is going to return -1. -1 means search is unsuccessful. So next we have discussed about binary search. What is the advantage of this binary search when compared with linear search? In the case of linear search, to reduce the number of comparisons, we are moving for binary search. So in the case of binary search, what we are doing, the first step is nothing but we have to perform sorting operation. That means the data should be arranged in an ascending order or a descending order, but probably we will use ascending order. Once if the data is arranged in ascending order, then so instead of comparing element by element, we will always compare the middle element in the entire list. Okay. Suppose if your result is available, then you will print the result. Suppose if it is not available, then so we are going to check whether the element is in the left part or right part of the list. Left part means what? The element which you are searching is less than the given element. Okay. So then how we are going to work? So we have seen very clearly. Suppose if it is in left part, okay, if your key value is greater than mid means what? This key which you are searching is not there in the left part. If it is not there in the left part, immediately you are going to increment low pointer to the next value. Like this we are taking. Otherwise, sir, your high value will become mid -1. Okay, your high value become mid -1. Like this we are comparing. So this is nothing but the technique which we have used in our linear binary search, sir. But we implemented binary search by using which concept? While okay, sir, same thing by using recursion we have implemented. Okay, so by using recursion, how it is going to work? But I want to demonstrate these by using this recursion. I want to explain. Okay, one more time, just by taking one simple example. So yes, now let me take some example and I will explain, because majority of the students not understood this. So consider I have a list array is there. So the elements are nothing but something like 11, so 12, so 13, 14, 15, 16. Like this, I have some elements are there. So here clearly you can able to see these elements are available in 0th location, first location, second location, third location, fourth location, fifth location, and sixth location. Now here assume the element which I want to compare. So key value is equal to, consider I want to search for 16. Okay, I want to search for 16. That is what is the output of this program? Yes, what output we are expecting? Can you please confirm? Yes, good. So we are expecting output as a 5. Now see what will happen. Sir, first of all, we are going to consider this as a low value. Okay, we have to consider so this as a low value, and we have to consider this as a high value. So what is the value of low? Your low value will become 0 and your high value will become length minus 1. What is the length? 7, right? So 7 minus 1 means it will become 6. Sir, okay. Is low value is less than high or not? Yes. Then we are calculating middle. What is the formula for middle? Low plus high by 2. 6 plus 0. 6 by 2 means 3. That means we have to compare the value of key with the third location element. Sir, what is the third location element? 14. So the key which you are comparing is nothing but a 16. Sir, is it less than 14 or is it equal to 14 or is it greater than 14? That we have to check. Sir, it is not there in the left side. It is not equal to middle, but it is greater than this this middle element, right? Sir, if your value, whatever located on the middle, if it is less than key value, that means key is greater means. So you are going to compare the elements in this part so that we can reduce these three comparisons. So how we are going to do that? Just we are taking the same values. Okay. Just we are going to take the same values like low value is going to change, but high will remain 6. Sir, what is the low? In the previous case, here is the now this will become that means what? Mid plus 1. What is the mid value? 3. 3 plus 1 will become 4. Now what is the new mid value? 6 plus 5. Sorry, 6 plus 4, which will become 10. Sir, 10 by 2 means what? 5 is the mid value. Now, what is the element located at the fifth location? Sir, the element which is located is nothing but 16. Sir, the element which you are searching is nothing but a 16. Okay. Sir, is the 16 is available in the middle or not? Yes, this match is found. So these two conditions are failed. Sir, if it is matched with the middle element, then what we are returning? Mid value. In this case, what is the mid value? Mid value is nothing but 5. That's why your result will become 5. So since it is a recursion, low value is less than high value. We will keep on searching. If anywhere middle value is not equal, then this entire if condition is false means at last it is going to return minus 1. Minus 1 states that that element is not existed in the list. Okay, this is nothing but what we have. So if you want just a matter of 1 minute, I will take a key value is equal to 10. So first time low will become 0. So your high value will become sir 6. Your middle will become 3. So what is the third location element? 14. Your key value is less. Sir, less means what we have to do? If your key value is less means mid minus 1. That means low will become same. Sir, your high value will become mid minus 1. What is the mid value? Sir, here we got mid value as a 3. 3 minus 1 means now your mid value will become so 2 plus 0, 2 by 2, 1. That means we are comparing with first location. Sir, again is it matched? No. Sir, your low value will become same 0 and your high value will become mid minus 1. What is the mid value? 1. 1 minus 1 means 0. Now your mid will become 0 plus 0, 0 by 2. That means 0. Now we are comparing that 10 with 11. Is it matched? No. Then what we are going to do? Sir, your low will become same, but your high will become mid minus 1. What is the previous mid? 0. 0 minus 1 means minus 1. Have you observed? If low is less than or equal to high, this process we are repeating. But 0 is less than or equal to minus 1. Condition is not satisfied. Sir, hence it will come out from this and it is going to return minus 1. Okay, so this is nothing but how unsuccessful searches are going to be happen. So these things I explained very clearly in the last video, sir. But anyway, at last minute, so I think explanation has not done for recursive style. Now you people got very clear clarity about this, right? Could you please confirm, do you have any doubts up to this? Right, sir. One more one more small announcement. Okay, so yeah, and one more small announcement, sir. This week, I am going to take the classes very slowly. Okay, so and maybe one or two classes may be skipped because the reason is, so I was in Bangalore for my personal work. So my mother eye operation is there. That's why. So I'm going to take some special works. That's why. So don't worry. This week slowly I will take the classes, and next week we will spend some extra time. Probably next week I'm planning for one 2 or 3 hours class. Okay, please kindly adjust. Yeah, yeah, no problem. Just normal cataract surgery. Already one eye got completed. Second eye we are planning. Okay. And still the people who have not received running notes, you can please be on the line. So I will at the end. Yeah, yeah. At the end I'm going to share running notes. The people who have not received running notes, please wait. Okay. Now, sir, next, shall we go for the next algorithm? Please confirm everyone. Right. Sir, now in the binary search, okay, I mean in the binary search, sir, we have performed starting from 0 to n minus 1, right? Now I want to do this searching algorithm in half. I want to search for half, okay, half binary search, half binary search. That means I want to search for the element in the first half. Okay, so first half or second half. I want to compare for first half or second half, or if you want, you can give in between which values you need to compare. So that three algorithms we will discuss. Okay, how many days would be the holiday? Akash, no, as of now, not yet decided, but I will inform you through Gmail, I mean through mail IDs, or I will post it in group, or I will keep the display. Okay, don't worry at all. Sir, now first let me check binary search. Okay, binary search version 1 already we completed. Version 2 also we completed. Version 3 I am taking. Sir, what is version 3 is nothing but, so I want to search for elements. I want to search for an element in the first half of the list. First half of the list. That is, first half of the list means what? 0 to. Can you please tell me what will be the ending location, sir? Is it n or n by 2? Can you please confirm? Is it n or n by 2? Can you please confirm? Good. So I want to search from 0 to n by 2. That means the element which you are searching is available in the first half or not. We have to cross check. Okay, right. So let me take an implementation for this. We will see how it is going to work. Okay, let me take a test.java. Yes, this algorithm is already there. Sir, I think no need to change this one. The only change what we have to do is nothing but here. So binary search, I want to take 0 comma a of, no, not required to change low and high, Chaitanya. The arguments you have to change, that's all. Okay, the arguments which you have to change here. So a dot length minus 1 by 2. Sir, compulsory you need to take this within parenthesis. Otherwise, what will happen? Division is having highest priority, right? That's why your output is going to be mismatched. Sir, now here you can able to see, I want to do an activity here. Just a minute. So after sorting, better to print the elements. So I is equal to 0, I less than n, I plus plus. So system dot out dot print of. So a of I want to take followed by space. After printing the loop, I need to take a print ln. And one more thing here. So system dot out dot println of. So array elements after sorting. Like this, just for our convenient purpose, I am taking. So now what we have to do here, just a minute, sir, please wait. Yeah, just wait for 1 minute, sir, please wait. Yeah, right. So I think everything is the same from here. Okay, better I need to read the key value after printing the elements so that we can get clarity. Right, sir, we are starting from 0th location, a dot length minus 1 divided by 2. That's all. So we are searching in the first half. Now let us run this first of all to get clarity. Yes. So cd space Prakash classes. So I'm taking Java C test.java. The code compiles fine. And I'm taking Java space test. So I'm asking enter array size. Maybe 6 elements I want to provide. Okay, let it be. Let us provide the elements in sorting order only. Otherwise, like this, I'm taking. Sir, you can able to see after array elements sorting, we got 11, 12, 13, 14, 15, 16 like this. So I want to search for 11. What output we are going to get? In 0th location, it is available. Now I am giving the same input, sir. Okay, I am giving the same input. Now I want to search for the element 16. Sir, in which location it is searching? In the first half, right? First half in the sense what? Only in these three locations it will compare, but outside it is not available, right? Sir, what answer we are getting? -1. Sir, it is there in the list, but again why it is not displaying the location means because we have implemented an algorithm such that if you pass the beginning location and ending location, it will search in between. So if you are giving beginning location and middle location, it will search only in the middle part. Okay, otherwise it will search only in this part. Like that, we have implemented the algorithm, sir. So this is nothing but how we can able to. Okay, now, sir, this version is okay. Okay, this version is okay, working fine. But if I want to implement, okay, if I want to implement, so in the right hand side, I search. So not from 0 to, okay, yeah, not from 0 to n by 2. Sir, I want to search from n by 2 to 0. That is nothing but a second half. Okay. Sir, how we can able to do that? Yeah. So version 4 I'm implementing. I want to search for element in the second half. Sir, second half of the list means what? I will take from n by 2 plus 1 to, sir, n. That's all right. Okay, n by 2 plus 1 to n. Okay, now, sir, what change we have to do? The program will be same. Only in the main method, here we have to take a dot length minus 1 by 2, again a dot length. That's all. Now it will search in which part? Right, right side part. Let me check. Sir, I am giving 6 elements. Sir, 11. I am giving 14. I am giving 12. I am giving 15. I am giving 13, and I am giving now press enter. Sir, enter value to search. So assume I want to search for 11. Sir, what it is telling? So -1. The element is not available. Sir, now I am giving so 11, so 14, so 12, 15, so 13, 16. Now I want to search for 16. Sir, in which location it is available? Fifth location. 0, 1, 2, 3, 4, 5. That's all. Like this we have. So hope you people got very clear clarity about this one. Okay, right. So how to search in the left part of the list and how to search in the right part of the list, I think you people got very clear clarity, sir. Right, any doubts up to this? Can you please confirm? Everyone, I request everyone to please confirm any doubts up to this. Right. So the next version which I want to cover is nothing but a fifth version. So I need to search for the elements in between the locations. Okay, I want to search for the elements in between the locations. Like, so I want to search for an element in between. Okay, in between low and high values. Okay, low and high values. So how I can able to take like this? That is, so I can able to say directly in between, sir, low to high, low to high. Sir, which one is inclusive, which one is exclusive? Compulsory you have to consider, sir. Can you please tell me which one is inclusive? Is low value is inclusive or not? According to the normal algorithm, is low value is inclusive or not? Yes, sir. So what about a high value? Is a high value is exclusive or not? Yes, because if you take 0 and normally n minus 1 we will take or not. I mean, if you take low value, a high value as a n, at the algorithm, you can able to see whatever high value you are giving, it will neglect that. Have you observed here itself? We are going to take -1. So that means why? What is the reason for that? Is nothing but we have to count one plus value, sir. So it is always a good programming practice to ignore the last value, because if you are coming from Python background, so in majority of the situations we are going to consider that. So here low value is nothing but inclusive, high value is nothing but exclusive. If you want, you can do the modifications by taking both inclusive, but which may create some confusion for you people. That's why just you can able to ignore. Okay, just you can able to ignore. And sir, what modification we have to do in the program? Because in the program you have to print, right? You have to check. Okay, you need to write the algorithm for that. So you have to give the inputs for low and high. That's why, sir, I am asking system dot out dot println of sir, enter starting location. Okay, to search. Similarly, integer, I am going to take low value. Okay, low value is equal to obj dot next. So now I will ask system dot out dot println. So enter ending location. Okay, enter ending location. In which location you want to stop the searching. So that I am going to provide start end or low high. I think it will be good for starting ending, right? Let me take that one. So here I am going to take So the variable name as a start. Then, sir, after this, what we have to do? You need to call this a search algorithm, sir, by taking, okay, by taking start, and here you have to take end. Here you have to take end. Okay. So I think it won't work because the problem here is, sir, this high value, whatever we are passing, will it works? Yeah, it will work. So now we will see. But if I want to identify this low and high, just we need to check manually. That's why at the time of array printing itself, sir, what I am doing is I will print index value, okay, followed by that array element. I'm going to print index value followed by that array element so that we can easily recognize the positions, sir. Now I will run this program, see what happens. Observe carefully, friends. So enter array size. I have 5 elements are there. Sir, consider the elements are triple one, so triple eight, triple three, so triple six, and triple nine. Like this, I am giving 5 elements. Sir, you can able to see 0th location, first location, second location, third location, fourth location. Enter the value to be searched. Sir, I want to search for triple six. Okay, sir, enter starting location. Array, I want to search from first location to third location. Sir, in which position it is available? In the second position or not? Yes. Now, same algorithm I am working. Okay, so enter 5 values. Triple one I am giving. So triple eight I am giving. Triple three, triple six, triple nine. Same values I am giving. So these are the array elements. So in previous case, we have given triple six, right? Sir, in which locations we have identified? So in between 1 to 3, we search. In between 1 to 3, because the elements are available. Now I want to search in between 3 to 4. Sir, what output I'm getting? -1, meaning that in that specified location, whatever you have given, so the values are not available. The values are not available. Like that, it is telling. Okay, this is nothing but another version what we have. Okay, so I think you people got a very clear clarity about this binary search, the last algorithm which we covered, right? Any doubts, friends, up to this? Can you please confirm? Correct, Vishal. Ishita, she is asking how these versions of binary search will be used in real-time scenarios. Ayo, ma'am, in everywhere we are using this binary search. Everywhere we are using this binary search. I think I have explained in the beginning classes itself some example. I mean, while taking this introduction part, see, whenever you want to search for the data, the internal algorithms are going to work in this fashion only. For example, consider. Yeah, most useful, correct. So consider you have sir, best example. Please don't mind, I'm killing the time. Please consider. So I'm taking one real-time example. Sir, when I'm working in one engineering college, so I was worked as an examination section in charge for a few days. Okay. So they are having some hall ticket number, students ranging from so 5012, okay, sir, 5 something like a 5B0 something, okay, 599. Like this, we have student details are there. Okay, so I think you people heard about this particular hall ticket numbers belongs to CSC students. So I want to search. So in these 100 members, okay, in these 100 members, some students are having supplies, some students are not having supplies. So one parent came, okay, one parent came, he has given the roll number as 564. I want to search for this 564. Sir, how I am going to search for 564? Definitely, I know very clearly that so in the first page the data won't be available. because the first page contains 5012, maybe up to 25 records or 35 records or 50 records like that. So what I will do, I will scroll my mouse. So until I have seen the second part. In the second part only, I'm going to compare. Have you observed? So this is the real-time sequence. In everywhere, the searching algorithm will be implemented in this style only. Okay, not only this one, everywhere. So if you want to search for the data, if the data is in sorting order, it is very easy to search the data. It is very easy to search the data because first we will trigger middle element. And if it is result is available, you are the luckiest person. Rarely it will happen. So otherwise, we will decide whether it is the left hand side or right hand side. Based on that, remaining comparisons is going to be compared. So it is a useful searching algorithms, right? Yes. Yeah, file manager also correct. Hmm. In Google Pay, searching for IFSC code, excellent. Even in the OTT platforms, if you are going to register with mobile numbers, right? All these mobile numbers will be arranged in the ascending order. So if you are giving some message, if you are logging in first time or you have changed the device, so you want to register for the Taha or Prime Logic, Prime or G5 like that. So what you will do, you will open the application. So you are going to type your mobile number. Within 1 minute, you are going to receive the OTP. That means in the 1 minute, how many lakhs of subscribers will be there? Your mobile number have to be compared with those lakhs of subscribers. If the data is available, so that algorithm will generate a OTP to you and it will give that OTP to admin. So that admin OTP and you have submitted OTP, both are same means, then associated credentials, associated profile will be shared for that Android or any other device. So when the customers are increasing, your searching application should not be decreased. Parallelly, they have to maintain. So in such cases, these are the best algorithms which they are using. Clear, Ishita? Akash, it is already installed in Mission. JDK is already installed in Mission. Okay. Now, sir, last version of binary search. Let me finish it. Last version of binary search. Okay. Sir, what is the last version of binary search? Binary search and version 6. Alright, don't depend always on user user defined algorithms. Okay. Sir, we can use a predefined sorting algorithms also for this purpose. Sir, which predefined sorting algorithm is existed for this? Very simple. Already we have seen arrays dot sort, right? Arrays dot sort. In the same way, arrays dot, we don't have any linear search, but we have binary search method is there. Okay, where it will take array name as the first argument. Okay, sir, starting location as a second argument, ending location as a third argument, and key value as a fourth argument. So it will search. Okay, it will search for the given key. Okay, it will search for the given key in between. Okay, in between start to end minus 1 in an array A. That's all. So no need to implement any algorithm. Directly it will take. If you want, you can able to see I am removing this binary search from here. I am removing this binary search from here, or let me remove this demo itself. Now what I'm going to do, enter array size. I'm reading the array size and I'm reading all the elements. So assume sorting I'm taking. Okay, for this also compulsory, the elements should be in sorting. Enter the value to be searched. I don't want this starting all these things. Sir, instead of demo, just you can take arrays. Arrays dot binary search is there. So which will take a starting location is 0, ending location is nothing but a dot length. Okay, a dot length minus 1, and then key value I'm giving. That's all. It will search automatically. So if you want, you can see here the method is not there. Okay, which sorting method internally it is going to use? As of now, it is not required for us, sir. Okay, sir, what is happening here? Binary search, yes, capital. See, listen carefully. Whenever you are taking the class names in Java, if a class contains more than one word, every subsequent word starts with capital. Suppose if you are taking method names, so first character in the method should be small letters. Subsequent characters will be always capital. Okay. Now listen carefully. Now it is going to work. So Java space test I am giving. Now enter array size 5. So I am giving the elements like this. Okay. I am giving the elements like this. Array elements are sorted. Enter the element to search. I want to search for sixth. Sir, it is printing -1. Something is wrong here. Let me check. Sir, 5 elements I am giving. Sir, 6, 1, 3, 2, 4. So enter the value to search. I want to search for 1. It is available. Maybe last location somewhere the problem. I think it has to read length, not length -1. So in our own implementation, we have included the value of h, but here it is not including because it is taking array size. So now I'm taking something like this and enter value to search 5 I'm giving. So it is available in fourth location. Suppose consider I want to supply 15243. Sir, I want to search for 34. Of course, we will get some different value. I don't want to continue on that negative value. I mean, I don't want to give the exact definition for that value. But remember, we will get negative value. If you are getting negative value, so that means the search is not successful. How many comparisons it has made at where the problem is coming, in which location the problem is coming, it is going to return. Okay. So, but no need to concentrate on that. Just assume if you are getting a negative value, then search is unsuccessful. Okay. So these are nothing but various searching implementations. Of course, not the types. We have only two types are there, but in how many versions we have implemented. So let me summarize. So in the binary search, okay, in the binary search version 1, what we have done in the first version, sir, normal implementation we have taken. Okay, our own implementation we have taken. And sir, in the second version, what we have done, sir, we have used recursive concept. Okay, recursive concept. Sir, in the third version, what we have done, sir, we have searched from 0th location to, okay, so n by 2. Sir, in the fourth location, what we have done, sir, from n by 2 plus 1 to n we have searched. And in the fifth location, what we have, fifth version, what we have done, sir, given starting and ending locations that we have compared. Then in the binary search, okay, in the binary search version 6, sir, by using predefined, okay, predefined method, so how you can able to search for an element. These things we covered very clearly in the last videos, sir, right? Any doubts on this binary search? Clear right up to this? Yes, right, sir. So with one small thing, I'm going to close this today's session. So, sir, there is arrays predefined class we have seen, right? In this, there is one special method is there with the name toString. Okay, so you have to pass an array as an argument for this method, sir. Sir, what this method is going to do? Okay, sir, it will read. Okay, it will read elements one by one. Okay, it will read elements one by one from an array, and it converts into the following string format. In the following string format, it will convert. Sir, what is that string format? Array first opening bracket. So we are going to take element 1. So followed by comma. Okay. Sir, again space plus element 2. Okay. Again comma followed by space plus element 3. Again comma, sir, space, element 4, and so on. Up to how many elements it is going to take? N elements it will take. Okay, it is going to take n elements. So plus, so I'm going to take, yeah, plus element number n minus 1. Okay, element number n I'm going to take. So again, it will close with these curly brackets. Like this it will take, sir. In this format it is going to return. Okay, so this is nothing but the beauty of which one? To string method. Okay, sir, if you take elements, for example, my array is having the elements 11, 12, 13, 14, like this. In which format it will print? 11, 12, 13, so 14. In this format it will print. Let us show you one simple example so that you can get clarity. Okay, so I have an array size is there, and I am reading all the array elements. So assume I am not doing sorting. Sir, here I want to print the elements. So array elements one by one. Okay, array elements one by one, like this I'm printing. Okay, so in addition to that, I want to print in a single line. Sir, what I'm doing here is system dot out dot println of, there is one predefined class is there with the name arrays. In that, which method we are discussing? To string. Just you have to pass that array and you will see the difference, sir. Now see what happens. Sir, I'm asking, I'm reading 5 elements from the user. Let us take a triple one, so triple two, triple three, so triple nine, triple seven, like this I am giving. You can able to see the array elements one by one in my own order. I mean, in my own style I have printed the array elements. But once if I pass this array reference to toString method, how beautifully this toString method got implemented. Okay, to return all the objects, all the array elements one by one in between these brackets separated by comma and space. Like this they have implemented toString method already in arrays classes, sir. Just we are utilizing this because in our upcoming classes every time we need to print the array. So every time if I want to print the array, so again and again taking the loop is not good, because we will try to insert a new element into the array. Okay, so after insertion, what is the array elements? Before insertion, what is the array elements? So instead of printing one by one, so better if I print that which is in the list format. So visualization wise it will be very good, sir. Right? So hope you people got very clear clarity about this two strings method. Right? Any doubts up to this? Right. Yeah, so that's all about today's session. Yeah, you can able to leave the session. Okay, remaining things we will continue tomorrow.